Yeah, actually, I'll introduce Dirk again. We have been putting on a presentation on the why, what, and how of preheat for a period of time. And what we thought, just to get the ball rolling here, is to go over some of the highlights and points that we've found by doing a lot of research, talking to our customers. And one of the things I hope that I can encourage during this webinar too is 90% of our great ideas are actually your great ideas. It's not stuff that we came up with. It's people like Mike and Travis and the people on the line here that say, hey, you know, we really need this and we really need that. Okay. I'm going to actually toss it over to Dirk, and he's going to take the first couple slides here and go through some of our basics of why, what, and how to preheat.
Well, it's real simple. We like to preheat. Probably the biggest thing is so the engine will start. One of the funny things that does happen when we try to start an engine under certain conditions is that we get a frosting of the plugs, which sounds kind of odd, but in fact it does happen not even at freezing sometimes, just because moisture is created as part of the combustion process. So when we heat the cylinder head, those things are eliminated along with cylinder taper, which piston engines, at least the horizontally opposed type, not necessarily radials, have about a 2000 taper in them, and that is reduced, so we cut down a lot of the cylinder scoring and things like that happen, and also blow by on the rings so that we introduce less pollutants into the oil and reduce the run-up time on the engine. So a lot of stress is reduced right down to vibration for engine mounts and also exhaust. And the way we do that, where we heat is we heat multiple points on the engine. Again, the cylinder heads or cylinder assemblies is the main item that we want to preheat, and that heat does transfer into the case, but we also add heat to the case, and we put a little bit of heat on the oil. All we want to do is make the oil flow. Most people are using multi-viscosity oils now, so we don't want too much heat on it. And again, we just want it to flow so it gets up into the crankcase, and then it's heated from the heating of the crankcase and the cylinder heads. So those are most of the reasons why we do it. It also increases safety. I've seen some engines that I pulled apart where I think main bearings have actually been spun hours before it actually showed up. So you may damage your engine in the winter on a cold start and not even have it show up for 10, 20 hours later, and it's here it is spring or summer, and you think, wow, I had a problem with my engine, and it's actually related to that cold start, that one cold start that took place. So those are some of the reasons why to preheat. We also have issues with torque oscillation, not so much here on piston aircraft, but more on turbine and especially on helicopters. And that's one of the issues they have with some of the designs right now with diesel engines that they're trying to put into helicopters. Just torque oscillation is very difficult to control, and it causes a lot of wear. We could talk a little bit on crankshaft clearance issues. And it sounds kind of funny. Normally when something gets cold, it shrinks away from its largest area of mass, but on crankshafts, it does shrink toward the crankshaft, just because we have so much mass outside of the on the rest of the case, as well as with the pistons. We have a tendency to shrink down on a cylinder right onto the wrist pin, and now we do machine those a little looser. We don't have the issues that we used to have as much, but that was a very common problem. Engine manufacturers, if you look in the surface information letters that we have available to us from both Continental and Lycoming, they recommend preheating at temperatures below 40 degrees. So if you think it's going to get down to 40 degrees or lower, then you should be preheating your engine prior to that time. And then we have in our operating manual, I usually recommend just going to those now. They're available on our website, and read through those. They're real simple to go through. We have a purpose and scope and then general information just in the very front page of that that give us good information on when to preheat. And we do reference and recommend that you follow the service information letters from the manufacturers, both Continental and Lycoming, and those two are available on our website as well.
I think, Paul, if you take and move forward, we've got examples of the service information letter. This is SIL 03-1, which is from Continental. It's an excerpt right from there where they're talking about when and why and how to preheat. And then the next slide we'll talk about will be the actual bulletin, service instruction bulletin from Lycoming, 1505. And there they even go and state, that it must have preheat done at a certain temperature, and that the use of a heated dipstick is not approved because the heat isn't distributed throughout the engine.
Yeah, one of the ones I wanted to cover, we get a lot of questions about, is the service information letter from Lycoming, the SIL 03-1. They describe engine preheating using a engine-mounted preheat system in Section C. We actually helped them write that. So we've been in touch with Continental now for a number of years, and they've been using our system and are quite aware of it. And there is a section in there that describes our system. It says in Section C there, engine head heater, they call it thermocouples. They need a engine mount or a cylinder mounted heater, as well as a sump heater and crankcase heater. One of the questions that comes up here is people say, right in it, it says to only operate it for 24 hours or less, but it also says to follow specific instructions provided by the manufacturers for the preheat system operation. So that's one of the reasons why we have a very clear operating guide for not only our piston, but our turbine and helicopter systems as well. Yeah, our system is a multi-point system, and just like everything in aviation, we want redundancy. So if we do have an element go out on a piston system, there's not that much of a problem. You can continue to use the system. We don't recommend that on our helicopter systems just because we have elements, all the way from the tail rotor to the main rotor gearbox, and we don't want a chance of scoring any bearings or anything like that with a cold start where you don't know that portion of it is out. But so far as a piston system, a lot of radiant heat just because it's under an engine cowl. Normally, if it's real cold, we're using a blanket included. We get radiant heat that heats the whole engine. So everything bolted to the engine on the accessory case is also heated up. Magnetos, vacuum pumps, things like that. It also reduces wear just having that heated. So that's the main reason we use a multi-point, and also to distribute the heat around. If we have a single point heating system, we'd have to put so much heat in one localized area. I've pulled engines apart where I have, I don't even want to go into the nightmares of burnt oil in the backside of pads that are over wattaged, right down to cracks and sumps and holes bored through them with electrical problems where systems are poorly designed. So that's one of the reasons we've gone ahead and taken our product to the next level of certification with the STC, for example, which allows us to have it looked at by the FAA a little closer and gives us an airworthy product that has better traceability as well. And I think probably
one of the things to add to that, Dirk, through all of the testing that we've done, we've determined from a piston engine, it's really important for us to heat that cylinder head up first, or at the same amount of time with more wattage than other areas, because we deal with moisture, and we'll talk about that a little bit later. Moisture can vaporize from the oil, and we want to make sure that all the parts of that engine are above dew point. So if any moisture that's already inside the engine is going to become moving around, that it does not have a place to condense on, and the only way it condenses if it's below dew point. That's why it's critical to go ahead and heat that cylinder head first. And then I think on the next slide, Paula, you'll see that we actually did some thermal imaging on that, where you can see.
We didn't do the thermal imaging.
That's true. Yeah. So it's actually a tech school institute, and you can talk a little bit about that, Dirk.
Yeah, and this is a real good example. I'm glad this slide is in here. One of the reasons why we do heat the cylinder head, of course, if you heat just at the base of the cylinders, like shown on this picture on the right side, what happens there is you don't get heat into the cylinder head. just strictly because you've got a huge mass of the piston, which blocks a lot of the heat transferring up into the cylinder head. And we want those rocker covers to be able to be lubricated right away so we don't have a lack of oil. Some of the testing I did with Pete here a number of years ago when we were designing the system took 15 minutes or longer to get oil up into the top of the cylinders. So all that, the valve train on the top of the cylinder was getting wear just because it was not getting lubrication. We also did some testing with those bands before our competitor here started using them. I did testing of my own Bonanza at the time. In fact, I cut the test short because the cylinder base temperature has exceeded what was called out in the type certificate data sheet. There is a temperature called out. Now Continental does spray oil, just like Lycoming does on the base of the cylinders, which does cut down on a lot of the temperature increases there. So we don't see those issues as much, but just was not a good place and conducive to our methodology of heating the engine thoroughly. When we put some heat on the case and then we've got in the cylinder heads, everything gets heated much more evenly and more efficiently. And again, like Doug was talking about, we don't have that transition area or a chance of a transition area from heat being on the crankcase and out to the cylinder heads. And that transition area would be in the worst place possible, and that's in the cylinders on the cast iron cylinder heads where you'll end up getting pitting and rusting due to corrosion if you do have a dew point. If you do hit dew point, have moisture collect in that area. So this is a real good example of that thorough heating that our system gives you.
Right.
And one of the things we do talk about in our operating guide is we don't tell you how to use the covers and things like that, but we do recommend getting a cover. And what our system does is it's designed to get the temperature of the engine to 60 degrees Fahrenheit above ambient temperature. So if it's 0, it gets up to 60 roughly above ambient. And if you have an engine cover over a cowl, of course the engine is going to be heated more thoroughly and more evenly, and that whole environment that the engine is sitting in is then controlled. And our systems are designed with a number of things taken into consideration, and one of them is that we keep the wattage down so that it's doesn't cost as much to operate, and so the systems can be operated with a small generator, as shown in the picture there on the right. That happens to be the Polar Pumpkin, which flew up to the North Pole, and that individual that owns that aircraft's been all over and clear down to the South Pole with it as well. And he has our system on it, and he operates it, as you can see here, with a small generator. In fact, he's built a little tent for his generator now that goes right underneath the engine. And then we also offer wing and tail covers and even fuselage covers. Some of the regional airlines use our systems all the way from the Preheat system to covers, wings, on all the appendages.
And then I'd like to jump in too, just a little bit more about Tanis, and then of course you've heard us talking, and I'll turn it over to the people that we have as panelists, because I would hope that everybody on the webinar would probably think that Tanis is going to speak strongly about our product, but we are passionate about it, and we do it. We have been in business for actually selling our product for 40 years commercially, and we are the only manufacturer that has our product as part of the type certificate of airframe manufacturers like Cirrus, Cessna, Diamond, Pilatus. We even did a test with Bombardier this past February up in Siberia with the Russian Federation on a cold weather soak at minus 48 degrees C temperature. And we've worked now with Viking, which is the owner of the Dash 6 in the Beaver product that they're now producing. And Dirk talked a little bit before about the STCs. When I came on board, we actually started the first STC on a helicopter system, on the Bell 429, driven by the customer outside the United States. And we STC'd that. Then we went to the 4-cylinder Lycoming Continental engines, the Augusta Westland 119, and now the 6-cylinder Lycoming Continental and Franklin engines. We have STC'd, and we did that not because you need an STC. In fact, it's a minor mod here in the United States, but our product, 30% of our product is sold outside of the United States, and we were finding it a necessary object to do. And I encouraged our staff and our engineers to go through that next step of FAA certification to get another outside entity to look at all of our documentation, all of our data, to answer questions that were being asked, and we had to be able to prove some of the answers. And we do also have not only our engine preheat, but we do battery systems available for turbine and rotorcraft, as Dirk mentioned. I know we have a couple folks on the line on the webinar that handle more than just fixed wing product.
Excellent. So here's some of the questions that I know you always get.
Yeah, and we would answer some of these right away and then turn it over. Our system is designed to get its maximum effect in 4 to 6 hours. And that being, we will get, as Dirk stated, 60 degrees above ambient between 4 to 6 hours of plugging it in. And how hot does the engine get using Tanis Preheat? That's 60 degrees above ambient. Some people say, well, what happens if I plug it in all the time? You can leave your Tanis Preheat system plugged in all the time, because after we overcome that 50 to 60 degrees above ambient, then the amount of heat that we're putting in is also leaving the engine. So you can leave it plugged in. The question that gets connected right directly to that is, well, what about some of the service information that says do not plug it in for more than 24 hours, and won't I get corrosion? The manufacturers had to address all preheat systems, and usually that is centered in where there's only heat on the sump and possibly too much heat, where the oil temp is getting to 160, 170 degrees, and the moisture is vaporizing and then collecting again on a cooler part of the engine that doesn't have heat. That's the low dew point. And of course, once you're condensing on a part that doesn't have oil on it, it could lead to corrosion. But we've done multiple tests, and we test it every year. Our system can be plugged in. Now, granted, if you're not going to fly it at all, then we talk about preserving it. And is an STC required? Not in the United States. It's a minor modification, so that is not an absolute requirement. We, of course, are pushing that route now because that's allowed us to take our product that's available here all over the world, and it does give that extra level of confidence to either your customer or the end users. And how long does it take to install a Tanis Preheat system? You know, that's always the catch, the tough one, and I'll probably let Travis talk more to that. It depends. You know, is the cowling already off? Are we on a single engine plane? And what other things are you doing at the same time? But we'll address that question from people that actually do it more, like West Metro Aviation and Mark.